Welcome back to Learn as you explore for another MBOT 2 tutorial. In this video, we'll implement a fun audio project using the CyberPi. We will detect the direction in which the robot is tilted and make the CyberPi play specific sounds for each tilt direction. Before we dive in, here's a quick way to support my work. If you're planning to get an MBOT too, you can use my Amazon affiliate link in the description. It won't cost you extra, but as an Amazon associate, I earn from qualifying purchases. Or if you just want to say thanks, there's a buy me a coffee link down in the description too. All right, let's jump in. Let's open MBlock and start a new Python project. Let's name the project. I'm going to call it tutorial 14 tilt sounds. Let's first add comments to define the structure of our program. I'm going to add a multi-line comment here. As always, we will start the program when button B is pressed, and we know that we can use the button B event API from our previous tutorials. When button B is pressed, the first thing we want to do is print on the display the words detecting tilt. We then want to repeat until button A is pressed the following instructions. First, we want to detect if the robot is tilted forward. So we will say if tilted forward, we want to play a specific audio track. So let me just say for now, play audio track 1. And similarly, if it is tilted backward, we want to play a different audio track. I'm just going to call it audio track 2 for now. And we're going to repeat the same for if tilted left as well as if tilted right. Finally, when button A is pressed and we're about to end the program, let's clear the CyberPi screen because we had previously printed detecting tilt when the program started. So we're going to clear the display after button A is pressed before ending the program. Now we are familiar with some of these APIs that we would use here because we've used them in our previous programs. For example, for the onButtonB event, we can use the API cyberpi.event.isPress, which is a decorator. For printing on the display, we can use cyberpi.console.println. To detect if button A is pressed, we can use the cyberpi.controller.isPress. The APIs that we need to figure out are for tilted forward. We've never tried this before, so this is new. Similarly, playing an audio track, tilted backward, tilted left, tilted right. We also don't know for play audio track 2, 3, and 4, but we are going to assume that there's just one API that lets us play different tracks. So as long as we find out what the API is for play audio track 1, we can change the audio track itself that we want to play, but use the same API. And finally, we also want to find out the API for clearing the display, because that's something that we haven't done in the past. So let's write down the list of APIs that we need to find so that it is clear. So we need tilted forward, tilted back, tilted left, tilted right, play audio track, and finally clear the CyberPi display. Let's head on over to the CyberPi Python API documentation page to find these APIs. As always, the links to the API docs are in the description. We are now in the CyberPi API page. The first four APIs that we need are related to tilt detection. Let's glance over the outline to check if we see tilt detection mentioned anywhere. It's not likely to be in the audio section, and the same goes for the display section. Sensing maybe, but looking at the subheadings, it's not really clear that tilt detection APIs could be in any of these. It may be in sensor outputs or other outputs, but it's hard to say. Let's continue looking. It could be in motion sensing. Posture seems like a place it could be in, but that isn't super clear either. Wi Fi, cloud services, broadcast, and events all seem unlikely. So we couldn't directly find tilt detection from the outline. In cases like this, we have two options. One is we could start with a likely subheading like sensor outputs and keep scrolling until we find tilt detection APIs. Another option is to do a browser search. So in your browser, you can hit Control F or Command F if you're on a Mac computer. Then type in tilt, and we found the tilt detection APIs without any scrolling. Here we see there are APIs for tilt forward detection, tilt back detection, tilt left detection, and tilt right detection, which are the four APIs that we're looking for. And we will use all of these since we want to detect all four directions of tilt for our program. Next, we need the audio playback API. For this, we can use the outline. We see the audio section, so let's go there. We see two APIs here, play until and play. Both take in the name of the music to be played, which the documentation says is defined by the table in this link. This table is the same one that's right here below the two API definitions. Before we start looking into which audio track we want to play for each tilt direction, let's figure out which of the two APIs we want to use, play until or play. Reading the documentation, it says that play until blocks the thread until the playing ends, whereas it does not say that for the play API. So what does blocks the thread mean? So what does blocks the thread mean? In simple language, it means that in our Python program, when we make a call to play until, which is the blocking API, the program will wait until the audio file is fully played back before executing any next instructions in the program. Whereas with the play API, it will start playing the audio track and continue executing next instructions while the audio continues playing. For our project, we want the audio to fully play and not get interrupted by any other audio track. So we will use the play until API. Now that we know that we want to use the play until API, let's go and figure out what sounds or what audio tracks we want to use for the different tilt directions. To do that, we can refer to this table, which is right down here. We have four tilt directions that we're going to detect, so we need four different audio tracks. Feel free to explore this table and choose any four out of all of these different audio tracks that you have available to you. I'm going to choose four different tracks here. So for tilt forward, I want to play start. For tilt back, I want to play laser. For tilt left, I want to play clockwork. And finally, for tilt right, I want to play jump. Finally, we need to find the API to clear the CyberPy display. Since it is not clear from the outline which subheading the clear API would be in, let's use our browser search function. Let's search for clear, and we have the cyberpy.display.clear API, which clears the CyberPy screen and is exactly what we want. Great! Now that we have all the APIs we need, let's get coding. First, before we get into programming the logic, we need to import any required modules. In our case, since all the APIs that we need are from the CyberPy module, we will simply import CyberPy. We can document the APIs by replacing all the question marks right here. Now that we have all the APIs, we can remove this section from our comments. Now let's implement the logic. The first thing we want to do is to start with the event decorator for button B press. So that is cyberpy.event.isPress, and the button we're looking for is button B. Let's name the function. I'm going to call it on button B press. The first thing we want to do is to print on the display detecting tilt. So we'll use the cyberpy.console.println API, and the text we want to print is detecting tilt. Now we want to repeat until button A is pressed, so we'll use the while loop here. So we want to repeat while button A is not pressed. So we're going to do cyberpy.controller.isPress and button A. The actions we want to repeat are first check if the robot is tilted forward. If the robot is tilted forward, we want the CyberPy to play an audio track for which we will use the play until API. And the audio track we want is start. I just realized that I missed updating the comments for which audio tracks we're going to play here. So let's do that now. First, we decided that for tilted forward, we want to play the start audio track. For tilted backward, we want to play the laser audio track. For tilted left, we will play the clockwork audio track. And for tilted right, we'll play the jump audio track. Now let's continue with our program. We want to do the same thing here, just that we want to detect different directions of tilt. So I'm going to copy and paste the tilt forward code and change the tilt forward to tilt back, and also change the audio track we want to play to laser. Similarly, we want to detect tilt left, and the audio track we want to play for left is clockwork. And finally, we want to detect tilt right, and the audio track we want to play there is jump. Finally, if button A is pressed and we exit this while loop, we want to make sure to clear the CyberPi display before quitting the program. Make sure to save your program, and that's it. I know you're excited to test this out on your robot, so let's first upload the program. Make sure that the robot is powered on and connected to your computer. Click Connect, select the COM port for your robot, select Connect again. Make sure you're in the upload mode, and finally click on Upload Code and wait for the upload to complete. Now for the exciting part, let's go test our program on our Mbot 2 robot. To test the program, let's first press button B. We see the detecting tilt message. Now let's tilt the robot forward. We hear the start audio track. Next, let's tilt it backward. That's the laser audio track. Let's tilt to the left. We hear the clockwork audio track. Finally, tilting to the right, we hear the jump audio track. Let's press button A to stop the program. Great job today! You've now learned how to detect tilt on the Mbot 2 and also how to play many of the predefined audio tracks. I hope you had fun. Be on the lookout for the next tutorial from Learn as You Explore. If you found value in this video, hit the like button and subscribe to Learn as You Explore for more Mbot 2 tutorials. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.